Today we're going to start our last page of lesson 6 in module 5 with a warm-up. This one I am going to let you do all the parts by yourself because we did one a couple videos ago just like it, the amusement park passes, where we first wrote statements to describe the cost of each pass. Then we worked a couple problems deciding which pass was the best for each person. Then we wrote an inequality, solved the inequality, and stated in words what that inequality represents. So you have the same thing here. First, you have to write a variable. So what variable you're going to use? What is it we don't know? Is it hours? Is it weeks? Is it cost? What don't we know? So decide which variable, and you should be able to tell by looking at this. Define it, and don't forget to write the variable and then describe it. Then write the cost for plan A, expression here, and then the expression for the cost of plan B. Then you have one problem where you have to decide which plan is best for Bob. So you'll use your two expressions here, show your work, and then decide which one's best. And last, just like on the former problem, write an inequality. Plan A is less than or equal to plan B. So you use your expressions from above and do a direct translation. And then last, just like we did on the other one, state the meaning in complete sentences. Okay, so go ahead and turn off your video. This is the best practice ever, is trying one of these all by yourself to make sure you're ready for the test. And if you make a mistake, who cares? I don't care. I don't know if you made a mistake, but you should care, because that's how you learn, by making mistakes. So go ahead and shut it off. Come back when you are done and we'll check it together. Okay, so I can see on this one, $20 per week plus $150 per hour, $550 per hour. So I can see our variable is going to be hour, or our quantity that we need to represent is hours. So H would be the best one. So H equals the number of hours. And we have the three parts there. H is the variable. It stands for number, and the units is hours. Next, we have to go to each plan and write an expression. So 20 plus $1.50 per, and now everywhere we see hour, we need to replace it with H. So $1.50 H, where this one is just $5.50 H. And remember, as I said before, when we did this one with the amusement park, this is the most important step of the whole problem, because you mess these up, then you can't get part B right, then you can't write the correct inequality, so the rest of the problem is wrong. So be very careful when you do those expressions. Okay, now let's see which plan is best for Bob. So he's going to go 7 hours. So plan A, the work would be 20 plus $1.50 times 7. Plan B, and I just like to write them both out so I only have to grab the calculator once, would be $5.50 times the number of hours. So now I'm all ready for the calculator, and I can see which plan is best. So we have the first one, 20 plus, whoops, turn on the calculator, Kim, that might be helpful. So 20 plus 1.50 times 7. And you can use parentheses or a time sign, it doesn't matter. I use parentheses just because there was a decimal there, but in the calculator doesn't care. So plan A will cost, and this is money, don't forget your second decimal place, $30.50. Plan B, 5.50 times 7 will cost $38.50. So we can see that plan A is probably going to cost, well, no, I guess we can't really make a statement. Never mind. I'm not going to make any conjectures yet. So the best plan for Bob, which plan is best for him? So they don't ask us for a sentence on this. So plan A would be the best. And we could write saves what, $8? So that was easy, right? Especially after seeing the amusement park one, you knew exactly what to do then. Okay, write an inequality. So A, so when I see A, I write down what A represents. 20 plus 150H. So 20 plus 1.50H is less than or equal to, so make the L for less than and then put the equal sign in as well. So 20 plus 1.50H, which is what A is less than or equal, and then plan B. So I pull plan B down, 5.50H. And you can see these are all just extensions of the direct translations that we did earlier. So put that in for A, put the symbol in for those words, put that in for B. So no tricky stuff, just direct translations. So this is the 4th time we've now seen one like these. They keep coming up. So when if we bring this over first, it's going to leave a blank. So either you have to remember to replace it with 0, or in the past we've said, oh, well, it doesn't matter. Move your constant over first, then you won't have nothing over there on that side. So that's the 4th time we've seen it. It's not really a very common problem, but it's funny how it just keeps popping up. So 5.50H minus 20. So we did that first step because constants move to the right, especially with the inequality. Now the variable expression should all be on the left. So do the opposite. Subtract 5.50H, or $5.50 times H. So it's gone on that side, which is our goal. We don't want any variables on the right. And so that's going to be negative 4H is less than or equal to negative 20. I'm just going to verify. Anytime I do something that's a little sketchy, I like to verify it just to make sure I didn't make a mistake. Yep, negative 4H. And then, oh, here's that again too. And I told you were going to see this a couple times on your test. We're once again dividing by a negative, and we learned that anytime you divide by a negative, you must flip the symbol. Only when this number is negative, which means the number in front of H is negative. Double negative, so this would be 5. And we know H is hours, so it would be, and this is the answer to that part right there. It said write your inequality. So H is greater than or equal to 5 hours. So do you guys all remember how I taught you to do the description? You repeat what you have there, and then you say when, and then repeat this. So plan A will be less than or equal to plan B when the number of hours is greater than or equal to 5. So plan A, maybe instead of less than or equal to, we could say costs less or equal. So cost is a better word for this one than is less than or equal to. So plan A costs less or is equal to plan B when the number of hours is greater than or equal to 5 hours. So you don't even have to make up your own words. Sometimes you can make this sound a little prettier. You just reiterate the problem and the answer. So let's do this. Excuse me. So from the top, I'm going to try and keep them both there. I'm going to make it a little teeny bit smaller so I don't have to keep going up and down. Maybe one more smaller. There we go. So plan A costs less than or equal to costs less than or equal to plan B when the number of hours is less than, whoops, slow down, Kim. That's a greater than or equal to 5 hours. So let's just make sure all the wording's right. Plan A costs less than or equal to Plan B when the number of hours is greater than or equal to 5. So at 5 hours, the two plans will cost the same. At 6 hours, Plan A's less. At 7 hours, Plan A's less. At 8 hours, Plan A's less. So Plan B would only be less if you were smaller than 5. So 4 hours, 3 hours, 2 hours, 1 hour. Okay, so hopefully that was a little bit easier after having done that example on page 3 in a earlier video. Okay, let's move on to our lesson. We are on page 4 of the lesson 6, module 5, lesson 6. We're on the very back page and it's just one big problem again. So page 4, continuing where we left off the last time. Okay, so what do we have here? Let's make it a little bit bigger to get back to the full screen. Stephen's instructor is grading his course based on total points. Not too many people do that anymore. Mostly teachers do weighted averages now, like the test costs 50%, the homework is worth 20%, the quizzes are worth 10%, but this is just points, so no weighting at all, so we don't have to worry about that. So he has 70 out of 95, and hopefully you understand that means this, just like when you get a grade on a test, he has 70 points out of a possible of 95. Here he has 82 out of 100, so we already know his quiz average. His quiz average is 82%. And then the test average is 140 over 160. So think about how we could find out what his grade is right now. So anybody have ideas like maybe adding these? this grade plus this grade plus that grade, and just add them straight across on the calculator. So 70 out of 95 plus 82 out of 100 plus 140 out of 160. Now this isn't really adding fractions, this is adding averages. So we'll add all the top numbers and then we'll add all the bottom numbers. So don't think of this as like, oh, I gotta find a common denominator. Not that kind of problem. So let's first add the numerators to see how many points he's scored so far this semester. So 70 plus 82 plus 140. And so he scored 292 possible points out of 95 plus 100 plus 160. Out of a total 355. So now you can pretend like this is a test. Here's your score in a test. How do you get your percent? You divide. So 355, whoops, Kim, backwards, 292 divided by, and we don't want to use a fraction bar on this one, we want a decimal. So when we want a decimal, we use the division key. When we want a fraction answer, we use the fraction. Divided by 355, and that gives us 0.82. So we can say approximately 82%, which would be a B with a standard grading scale. I don't think they ever say what the grading scale is, but we'll just say it's a straight 90, 80, 70, 60. So there's the percent. 2 followed by a 2 says he's at approximately 82%. And they didn't tell us how many places to bring it out, so I guess whoever made this packet doesn't think that's important. And at our school, it is super important because we only want exact answers unless asked to round. But we're getting the point across. Now we know how to find the grade. Add all the points they've earned, add all the points possible, divide the 2, and that will give you a percent. Just like when your teacher writes 82 over 100 on your test, 82 divided by 100 is 0.82, 82%. Okay, so now next, Stephen's instructor is going to give a culminating project that will be worth 80 points. Write an equation or inequality that models what score Stephen should get in order to have a B in the class. So, trying to think if we can use fractions for this, because if you use fractions in an equation, then they're real fractions. So I think we have to use the 82%. So 82% plus, I think I have a way. So we have 292 out of 355 plus how many out of 80, and it says he needs to earn to have a B, so that means greater than or equal to 80%. So he has to have a B or better. And that's why we have the greater than sign. We can't have less than 80, then that could be a C. So what we're going to do is exactly what we did up here, 292 plus X all over, and then the denominator turns into 355 plus 80. So what was that again? 435. So we don't know what he needs on his project. That's what we're figuring out. But this is the total points he's earned, and this is the total points possible. And we need that to be greater than or equal to 80%. So we can probably guesstimate that he needs either a low B or a high C to keep his B, right? So we'll kind of know whether our problem is correct once we get the answer. So first thing I would do, get rid of that fraction. So you can simply say multiply both sides by the LCD. So there's only one denominator, 435. So multiply this side by 435 and multiply this side by 435. So this side, it will immediately cancel because remember when you write it up there, it's like an extension. Anything divided by itself is 1. So we're left with 292 plus x equals 435 times 0.080 or 0. Whoops. That's why I love this calculator. Just back up 0.80 times 435. 348. So this is going to tell us how many points, write an equation that models a score Stephen will get out of 80 in order to keep his B. So subtract 292 from both sides. And remember, this is not a percent. This is points. How many points out of 80, not what percent out of 80. And we should have written that here. X equals number of points earned on project. We can just put project here instead of writing all those extra words. So the number of points earned on his project. So X equals 348's already in the calculator, so we can go minus 292. And he needs to get 56 points in order to keep his B. So don't write percent, it's points. And if you wanted to see what percent it was, remember how I said I bet it has to be a high C or a low B? Do 56 divided by 80. Oh, straight on C. We'll give him, on the project, we'll still give him a B in the class. But they didn't ask that. They said what score? So he needs to get 56 out of 80. They didn't ask for a complete sentence, so we can just write that. So that must be his score to maintain his B as a final grade in the class. Okay, so next it says solve the equation. Oh, write an equation that models what score. Oh, we just did two parts together, didn't we? Solve the equation inequality, which we did, and explain incomplete sentences. I knew there was going to be a complete sentence. So Stephen must score 56 out of 80 points on the project to keep a B in the class. And you'll see a lot of teachers require full sentences. That's why we started early in the pre-algebra class that you're in, so that you're used to it and understand it and realize that you can't just solve a word problem and circle the answer and have no idea what it is you found. So this is great practice because all your upper level teachers will have you write full sentences. So Stephen must score 56 out of 80 points on the project to keep a B in the class. Okay, now they're trying to trick us here. Can Stephen earn an A? So we can use this exact same equation or inequality, but we just need to change that to 90. And I'm not going to tell you the punchline yet, so we'll keep the inequality and then we'll go from there. So 292 plus, oh yes, x out of 435. Is it possible to get greater than or equal to 90%? And so I was going to give you the punchline and show you how you could tell if he could, but I'm going to wait and see if you guys can pick up on it. So do the same thing. Instead of still multiply the 435, but instead of multiplying it by 80%, this time we'll be multiplying it by 90%. So everything else is the same. This still cancels. Anything over itself is 1. So now we have 292 plus x is greater than or equal to. And this is why earlier I said don't think of the answer as percent. Think of the answer as points. We want to know how many points he must get out of 80 to get an A. So 0.90 times 435, 391.5. And then solve it just like we did before. Minus 292, subtract 292 in order to bring all your constants over to the right. So his score must be greater than or equal to, we got our 391.5 there, so just hit subtract 292. 99.5. So what the average student does is they convert this and think percent. Oh, if he gets a 99.5%, then he'll keep an A. But we're not doing percents, we're doing points. And the number of points possible is 80. He can't earn 99.5 points on an 80-point project. So we would say Stephen cannot earn an A because it's impossible to get 99.5 points on an 80-point project. Oh dear. Really slamming it in here, aren't I? So Stephen cannot earn an A because it's impossible to get 99.5 points, because remember what we wrote for X there. X is the number of points earned, not the percent. On a 80, would that be an 80-point project? I guess I needed there. 99.5 points on an 80-point project. There we go. So that one's a little tricky. I could really see students struggle with that on a test. I've never put one like that on a test because usually when I put one, it's all percents. So I'm not trying to confuse students. This one definitely, I could see confusing students. Oh yeah, if he scored a 99.5%, but we got to see what X stands for. It's not percent. It's his points earned out of 80. Okay, so that is the end of lesson 6. Only one more lesson to go. Woohoo! Okay, I'll see you back in lesson 7, and we'll do those last 2 problems on your practice test as well as the 2 pages of lesson 7. See you then.